Hi everyone. Okay, so last time I told you, one, we don't really use polynomials all that often in fitting functions. And two, that even if we wanted to, there's always some error and it really will obscure the underlying relationship. So what do we use if we can't really see all those fine details of that relationship? Well, what you typically use is something called a power function. It works great, and we'll see why we use it in just a second. So for these two trend lines, it's actually the same exact data we had just earlier, but this is before error and this is after adding some error. Now you can see that that relationship is still very clear. It really hasn't done much to change it. I mean, you would think that if I fit a third order polynomial, it'd be exactly the same, right? Right? Well, let's try and see. Click it, right click it, add trend line, and polynomial third order. Beautiful, fits it. And let's display that equation and r squared value on the chart. Okay, r squared value is equal to 1 because there's no error, so it fits it perfectly. And it's got that beautiful form. Magnifique. Okay, click this one down here. And I'm going to right click it and add a trend line. And same thing, third order polynomial, display equation on the chart, and display r squared value on chart. Do you notice something slightly different here? Does that look like it's fitting it very well? Now, once again, I look at this and I can't really see a difference. Can you? I mean, visually, these two are very, very similar. Similar magnitude, they're in a similar place, similar slopes, and yet when I fit that trend line, Excel goes bonkers. It's trying to say that this is the best way to do it, and maybe it is. But this is no longer fitting the data nicely at all. So if you fill this in, you can just kind of see that those values change dramatically. Like if we look at the terms, just look at the terms here. This is kind of amazing to me. I'm not going to fill it in because I'm going to talk about it instead. So plus 50 plus 86,934. Woo! Plus 16x minus 23,298x. Woo! Sorry, maybe the woos are a bit much. Minus 25x squared plus 741.97x squared. 4.8, negative 2.166. That one's not that bad. But you can see here that this shows two completely different functions. They don't even have a similar shape when we log scale them. If we didn't log scale them, they would look kind of similar, but otherwise, not the same thing. So this is the issue with polynomials. They're very sensitive. They're very sensitive to error. So if there's error, it will change the form of that polynomial dramatically. And also if I take away or add data, it's also going to change dramatically. So not a good thing. And just to make sure that I program this right, 86934. Okay, it's all good. Those numbers seem big for me. So remember this. Those trend lines that you add, polynomials are usually not the right answer because they can make some big mistakes. I accidentally deleted all this. There we go. And I'm going to delete this trend line right here as well. Perfect. Okay, now what we would add instead is a power law type trend line. Power law. Power! It's very similar in a way to the polynomial, except there's just one term with a non-unit power of x. So for polynomials, it's x to the fifth plus x to the fourth plus x to the third. Power law is just like x to the 2.758, whatever. It has some power. So I right click, I add trend line, I choose power relationship and display equation on chart. Now, if you look at it, it doesn't fit it perfectly down here in the trough. But with the polynomial, when we added error, it didn't either. So it's not perfect, but it's pretty dang good. And in the end, when we're at low values, we'd probably have so much error that we wouldn't be able to see this as finely as we can right now. and 0.936 is not shabby. Okay, and then let's look at this again. Actually, I want to blow this up a bit for you. There you go. And we're going to do the same thing right here. Right click, add trend line, power law. Display equation on chart, display r squared value, and let's look at this one. So first off, you can see that it looks the same. It fits it the same, like it doesn't change the shape of the trend line really at all. And if we look at its form, it's also extremely similar. The the constant out front did change slightly, but not nearly at the same magnitude that it did for our previous polynomial example. And the power of x is almost exactly the same. So this relationship is almost the same slope if looking at log scale. So this is a good thing. We don't want our equations to change much with addition of error or addition of new data, or if we remove data. If they change when we do that, it's probably not a good equation to describe your data. So we've done it. We've added power laws. Next time we're going to jump into something completely different. We're going to learn about exponential and then logarithmic functions. So I hope this helped you, and I will see all of you next time. Bye-bye.